So now we know what a random variable mean. So the next thing we're gonna discuss is what is the probability of a random variable. So when we talk about the random variable, associated with each of the outcome for your random variable, there will be a probability. So if we create a table that would include the probability for every possible outcome for the random variable, we would call that table or that chart a probability distribution. So a probability distribution is a table, or it could be a graph that's providing the probability for each of the possible value for the random variable. So let's look at a specific example for this. So the experiment here is that if you tossing 3 coins and x represent the number of tails that come up, we want to construct the probability distribution of this variable x. So here x represent, let me move this. So x is the number of tails that come up when you tossing 3 coins. So let's say if I have, think about this. So if you're tossing 3 coins, what are the possible value for the number of tails that you could get? So if you toss 3 coins, all of them could be head, and in that case, that means that you would have no tail at all, right? So one possible outcome for this would be, so let's see how I'm gonna draw my probability distribution. This is one way to do it. So you could have zero tail at all, right? Okay, so that's one possible outcome, because if you toss 3 coins, if one of the outcome that you get is head, head, and head, if all of them are head, that means you get 0 tail. So now what are the other outcome for this x? Well, you could have one tail, right? So one tail could be, you could have tail, head, head, that's one, right? That's give you one tail. Or you could have head, tail, head. Or you could have head, head, and tail, right? So these are, there's a total of three outcomes that has one tail, where we have one tail. So in this case, another possible value for x would be 1, because remember, x represents the number of tails. So you could have, the first one was if you have 0 tail, which means when you get all of them ahead. But then you could also have 1 tails. So based on this, you could see that, well, we could also have 2 tails, right? So another possible value for x would be 2, right? You could have 2 tails. So what are the outcome that would give a 2 tails? So let's look at that. So let's say 2 tail would mean I need tail, and then head, right? That's one possibility. Or you could have head first, and then the other 2 would be tail. Okay, so head, and then tail, and tail. Okay, you could have tail, head, and tail. So again, there's three outcomes here, where we have 2 tail. Where we have 2 tails. Okay. Now the last. Okay. So so far we have 3 possible values for our random variable x. So we could have 0 tail, or we could have 1 tail, or we could have 2 tails. Well, but we tossing 3 coins, so another possibility for the number of tails that we could get could be 3 tails, right? So that's going to be, our x could be equal to 3. Okay. So now let's try to determine what is the outcome that would give us 3 tails. Well, there's only one such outcome. That's when you get all three are tails. So all three are tails. So this is the case when you have three tails, right? Three tails. Okay. So now, in order to complete our probability distribution, we have to figure out the probability for each of these random variables. So, for example, how do I find the probability for getting 0 tail? How do I find the probability for getting 1 tail, etc.? Okay, so that's what we're going to do next. So we use this notation P of x. Well, you've seen this notation before. We discussed P here stands for probability. So the probability of obtaining a specific outcome. So the first one would be what is P of 0, which means what's the probability of getting 0 tail when you're tossing 3 coins. And the way that we approaching probability problem is that we look at the total number of possible outcomes in the experiment. Well, the experiment here, you're tossing 3 coins, and then you look at how many possible outcomes that you could have when you're tossing 3 coins. Well, we list all of the possible outcomes here. There's a total of 8 possible outcomes in this experiment. 8 possible outcomes when you're tossing 3 coins. Now, out of those 8 possible outcomes, there's only one outcome that would give us 0 tail. So the probability of getting 0 tail would be 1 out of 8. And so that's going to be 1 out of 8. Okay. And this is something that we have done in the previous chapter, on the probability chapter. So we have discussed how to do this before. So now we just apply it, apply what we learned from chapter 5 to do this question. Okay, so that's good. Now let's move on to what is the probability that we could get 1 tail. Well, if you look at the possible outcomes that we have, there are 3 outcomes where we have 1 tail. So that's going to be 3 out of 8. So the probability of getting 1 tail is going to be 3 out of 8. Similarly, the probability of getting 2 tails is also 3 out of 8 as well. And last but not least, the probability of getting all 3 tails is going to be 1 out of 8, because there's only one outcome that would give us 3 tails. Okay, so if you observe this probability distribution table, you see that each of the probability is always less than or equal to 1, and it's also greater than or equal to 0. So this means that, this relates to the idea that we discussed in chapter 5, which was that the probability of an event is always between 0 and 1. So the maximum it could get is 1, and the minimum it could get for a probability is 0. And if you add each of the probability here, then what do you get? So you take 1a plus 3a plus 3a plus 1a. You would get a over a, which is equal to 1 or 100%. So these are the 2 important properties for a probability distribution. You see that the sum of the probability of all of the events in the sample space must be equal to 1. And in notation is this: the sum of the probability of x is equal to 1. The second thing that we notice is that the probability of each event in the sample space must be between 0 and 1 inclusive, which means that it could be 0 or 1. And in notation, that means, we use the inequality notation to say that the probability of the random variable x always stay between 0 and 1.